Good morning, dear students. In this class, we will discuss some problems on series connection and parallel connection of inductance, resistance, and capacitance. Okay, the first problem is like this: a circuit containing resistance of 52 ohm, inductance of 0.3 Henry, and capacity of capacitance is 40 into 10 to the power minus 3 farad. An AC source of 200 volt and 50 hertz is connected in series. Calculate impedance, current, whether it leads or lags, and find the phase angle, they said. So let's write what are the given datas in the given problem. So given datas are, first resistance, let's write resistance is 52 ohm, then inductance L is 0.3 Henry, and capacitance of capacity is 40 into 10 to the power minus 3 farad. Then they had given E is the source, an AC source. E is 200 volt and its frequency is 50 hertz. So what they have asked, first question they have asked impedance is Z. Then they have asked for the current. Then whether it is lags or leads they asked, and phase angle they have asked. So we know that the impedance formula, impedance Z is equal to square root of R square plus omega L minus 1 by omega C to the square. So this is the formula we know. In this formula we should calculate these two factors. So let's calculate those factors. Omega L, so generally we were writing that as XL. So omega means 2 pi F, L is the inductance, 2 into 3.142 into frequency is 200 volt, 50 hertz, frequency is 50 hertz, okay, into, let's write here, into, then what they had given in the formula, inductance is there, that is 0.3 Henry. So let's calculate with calculator. 2 into 3.142 into 50 into 0.3. So we got reactance of inductance is 94.26. Then generally we are writing XC, that is 1 by omega C, isn't it? 1 by omega C, that we can write 2 pi F instead of omega C as it is. So 2 into 3.142 into 50, that is F. C means here 40, let's write 10 to the power in the numerator, that is plus 3. Okay, let's calculate with the calci. 2 into 3.142 into 50 into 40. Okay, this is what 10 to the power 3 divided by 12568, that is 1000 over, the answer is 0.0795. So this is our 1 by omega C. Let's substitute these two values in this formula, that is R square. R is 52, okay, 52 square plus omega L. Omega L is 94.26 minus 1 by omega c is 0.0795 to the square. Okay, let's write this 52 square as it is. So we have to subtract 0.079 in 94.26 minus 0.0795. Okay, so what we got, 94.18, okay, to the square. So let's square this. So we got that as 8869.95. So 52 square is 2704, plus we have to add this 8869.95. okay, what is the answer? So this is the square root of 11573.95. the square root of answer is, this is 107.58. this is impedance. Impedance is in ohm. Okay, next what they have asked, they have asked for the current. Current I is equal to E by Z, that we know in the derivation. E means 200 volt. Okay, this is 107.58. okay, this is 10. Okay, this is 200 divided by 107.58. so we got that as, so the answer is 200 divided by 107.58. so we got current as 1.859. now this is our current. Current is in ampere. Let's write A. Then they have asked whether it is leads or lags. So we know the condition omega L is greater than 1 by omega C. If then the applied current is leads. Omega L, what is omega L? Omega L is 94.26, which is greater than 0.079. So that's why the condition is greater. So that's why here the applied EMF will leads the current. Okay, then one more thing, we have to calculate for the tan pi, that is a phase angle. So let's calculate that. So let's calculate tan pi. Tan pi, that equal to omega L minus 1 by omega C whole divided by R. This is the value we know, omega L. Substitute the value of omega L, that is 94.26 minus 1 by omega C is 0.079. 0.0795 divided by R is 52. Let's calculate now. So what is the answer? We will get, let's see, 0.0795. So in the numerator we got 94.180 divided by 52 over 52. We got 1.811 as a phase angle. Sorry, this is tan pi. Tan pi 1.811. We need pi, that is tan inverse of 1.811. So we have to calculate tan inverse of 1.811. Okay, we got 61 degree nearly. We got 61 degree. Okay, so this is the phase angle. Here one more problem is there in parallel connection. So the question is like this: a resistance of 10 ohm, inductance of 1.1 Henry are connected in parallel with a capacitance 10 to the power minus 4 farad. Calculate the frequency of which the current is minimum, they have asked. So given data is R is equal to 10 ohm, inductance L is equal to 0.1 Henry, then capacitance C is equal to 10 to the power minus 4 farad. Then what they have asked, frequency they have asked, that is F is equal to 0. So frequency formula we know, F is equal to 1 divided by 2 pi, 1 divided by 2 pi into square root of 1 by L into C minus R square by L square. So 1 divided by 2 into 3.142 into 1 divided by L is 0.1 into 10 to the power minus 4. Okay, minus R square is 10 square is 100, L square is 0.1 square. Okay, let's write like this. Okay, then it will be like this: 2 into 3.142, so that is 6.284 square root of, let's take this 10 to the power 4 to the numerator, so it will become, okay, divided by 0.1. we got as 10 to the power 5 plus 5. Okay, here we got 0.1 square is 0.01. 100 divided by 0.01 means this is 10 to the power 4. 10 to the power 4, 5 minus 10 to the power 4, 10 to the power 5 minus 10 to the power 4 is square root of 10. So we got square root of 10 is 1 divided by 6.284 into 3.162. Okay, so 3.162 divided by 6.284. We got 10 to the power